Hello, my name is Beth Dixon, and this is part 3 of a video series based on Vicki Borlaug's presentation on the standard normal table. At Walter State, we are using a standard Z table that gives area to the left. If you are using a different type of table, you do not need to watch this video. Before beginning this video, you will need to have access to a standard normal table that gives the area to the left. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this video series for students. In our next example, we have the third type of inequality. In parts 1 and 2 of this series, we have covered less than and greater than. And we now have done those two types. The only option left for us is to find the values in between two z-scores. The answer to the next example is the area between two z-scores. However, the table only gives us the area to the left. So if we have two z-scores and we're looking for the answer between those two z-scores, if we look up the first z-score, it will give us the area to the left. Notice the red outlined area. That is not what we're looking for, which we have shaded in the green. If we look up the second z-score, notice it also gives us the area to the left, the area outlined in blue. Again, that is not the area we're looking for. Actually, it's the tail of the red area, and notice what we have as we look at that. So to get our answer, we will subtract the smaller table value from the larger table value. If I subtract that blue tail from the area of the red tail, I should be left with just the green area, which is our answer. So to get our answer, we will subtract the larger table value minus the smaller table value. In other words, as we're doing the in-between, if we're shading in between, we shade between the two values, and our answer will be table minus table. Let's look at example number 7. Find the probability that negative 0.75 is less than z, which is less than 1.03. In this case, we need to find the probability that the z value is greater than negative 0.75 and less than 1.03. In other words, find the probability that the z value is between negative 0.75 and a positive 1.03. The z is between those two values when you look at it, and that's what it really means. The first thing that we want to do is to draw our curve and mark the two values. Negative 0.75 to the left, the positive 1.03 to the right of the 0. Since z is between those two, we will shade between those two values. That will be our answer. First, we will look up 1.03, the 1.0 for our row, the 0.03 for our column, and that gives us 0.8485 as the area to the left. Notice that I'll outline that in red, and that shades from the 1.03 all the way back to the left. That is not our answer. Our answer is less than that. If we look at negative 0.7 and 0.05, that will give us the area to the left for 0.75 as 0.2266, which is the area to the left. Notice that is the area to the left of 0.75, which is none of our answer. That is the tail part, and if we subtract that from the previous area that we looked up, that will leave us our answer. So our answer will be 0.8485 minus 0.2266 to give us an answer of 0.6219. Let's look at a second example. Our example number 8. Find the probability that negative 1.56 is less than z, which is less than negative 0.39. We need to find the probability that the z value is greater than negative 1.56 and less than negative 0.39. In other words, find the probability that the z value is between negative 1.56 and negative 0.39. Once again, draw your normal bell-shaped curve with 0 in the center. Mark both the negative 1.56 and the negative 0.39. Both of those values will be to the left of the 0. We will shade between those because for between, you do shade between your two z values. Look up both of those numbers. For negative 0.39, you will get 0.3483, and that is the area to the left, shaded in red or highlighted around in red. Notice how Ms. Borlaug uses an arrow to point to that area. Sorry, my phone went off. I had to turn it off. Now the next part, we have to look up negative 1.56. We look that up and we get an area of 0.0594. That again is the area to the left. That part is outlined in blue. We will need to subtract that part from the red area, the red outlined area, to find our answer. And you can again see how those arrows help us to see that. That then gives us 0.3483 minus 0.0594 to give us an area for our answer of 0.2889. Here is a student activity for you to try. And here is a class discussion. Why are these two probabilities equal? One is the probability that z is less than 2.61, and the second one is the probability that z is less than or equal to 2.61. First, think about the difference of the two statements. The second statement only adds the number of 2.61 itself. That's the only difference in the two statements. So what would the probability of z equaling 2.61 be? Well, if we use the last technique in inequalities that we learned to find that probability, we would end up with a probability of 0, since that would be the probability of it being between 2.61 and 2.61, and the area of that would be subtracting the two areas from each other, which would be 0. Since adding a probability of 0 to the second statement wouldn't change the value, we can actually say that these two statements are equal. This is a great place to stop. We'll pick up with topic number 3 in part 4 of this series. Thank you for watching.